now we're going to solve integrals using the technique of partial fractions. Now, many integrals can be done in more than one way. For example, if you just have the integral of x squared plus 9, you don't need to use trig substitution. You can integrate x squared and then integrate 9 and add them together. Now we have the integral of dx over x squared minus 1. One would say, well, that's a classic trig substitution problem. Another way of doing it is to realize that it's 1 over x squared minus 1 times dx. Let us look at that a little bit more closely. 1 over x squared minus 1. Well, I can factor the x squared minus 1. I can factor it to x plus 1 times x minus 1. And I claim that I can even write it as a sum of fractions where one denominator is x plus 1 and the other denominator is x minus 1. Since x plus 1 is to the first degree, what goes on top will be a polynomial 1 degree less. 1 degree less than 1 is degree 0, which is a constant. For example, if I had x cubed plus 4x minus 9 in the bottom instead of x plus 1. Well, that's a cubic. The highest degree is 3 in the bottom. So in the top, I would put a number times x squared, 1 degree less, plus a number times x, plus a number. I wouldn't just put ax squared. I'd go down to a constant. Plus, since the highest power of x is 1, what goes on top is 1 degree less, which is just a constant. Now the question is, what are the a's and the b's? For example, so I have 1 over x squared minus 1, and this is a over x plus 1. I want to motivate what I'm doing before I continue. If I integrate the left side dx, well, then I can have to integrate the right side dx. But when you have a sum, you can integrate separately. But then the right side is easy to integrate. You can pull a constant out in front. This integral is just ln of x plus 1 in absolute values. Plus, then I bring the b out in front. Dx over x minus 1. Again, if I called that u, well then du is on top. Well, that's ln of u, which is x minus 1. I can integrate it that way. But I can't do it just yet, only because I don't know what a and b are. So now we take what we have, top and the right, we take what we have here, and as though we're going to come back to it, we want to get the same denominator now. We want to get a common denominator. X plus 1 times x minus 1. Well, in order to do that, I need to multiply the left fraction by by 1. I want to change the way it looks. That is, I have to multiply it by 1. The way I'm going to pick the 1 is x minus 1 over x minus 1. And for the b over x minus 1, to get this to be the denominator, I need to multiply top and bottom by x plus 1. So what I get on the numerator is just what it says. I get a times x minus 1 plus b times x plus 1. So for one reason or another, I want to write down 1 over x squared minus 1. And I want to clean up the numerator. I want to distribute the a. So I get ax minus a. And do the same with b. Plus bx plus b. Plus bx plus b over x squared minus 1. And then in the numerator, I want to collect like terms. Like here we have ax's, and I'm adding b more x's. So I'm going to have a plus bx's. And the constant is plus b minus a. I hate starting off with a negative term. So the constant is plus b minus a. Now, if two fractions are equal, like these are, and the denominators are the same, then the numerators must be equal. You can't start off with different numbers in your calculator and divide them both by the same, like x squared minus 1, and get different answers, and get the same answer. The only time you're going to get the same answers is if the numerators are also the same. For example, if I told you that 2/3 is equal to some number over 2, whether I write it's x over 2 or box over 2, I meant to say over 3. What goes on the top is 2. X must be 2. If x over 7 is equal to 3 over 7, then x must equal 3. Okay, so 1 must equal to a plus b x's plus b minus a. Now here's where a lot of students, they just don't want to get this. You need to realize, again, this is equal to 1. It says so. But 1 is 0 x's, which is 0, plus 1. That is, a plus b must equal 0, plus b minus a must be 1. The number of x's must be 0, and the constant must be 1. Well, if I add these two quantities, if I add them, a plus negative a cancels out. But the b plus b does not. B plus b is 2b, 0 plus 1 is 1. So b is a half. And if you add a to it, if you add a to b, you get 0. So a must be negative a half. And all of that just to get a and b are a half. So remember, this integral used to equal this integral. Well, I should say integral is integral, dx is dx. But 1 over x squared minus 1, though I wrote on it a bit, sorry, but it equals this, without the stuff in the red. It equals a over x plus 1, where a is negative a half. It equals a over x plus 1 plus b, which is a half, over x minus 1. Okay, I'm going to erase an awful lot, and now we're going to integrate this mess. Integral over sum is the sum of the integrals. I'm integrating a sum, so I can sum the integrals. I could take the integral of negative a half over x plus 1 dx and add the integral of 1/2 over x minus 1 dx. Whole constants in front. You always have a 1 left. You can always multiply by 1. And 1 times dx is dx over x plus 1 times 1. Bring the half in front. Then you have the integral of 1 times dx, which is dx, the x minus 1. If I call that u, then du would be dx. That is, I have minus 1/2 the integral of du over u. But that's the integral of ln of the absolute value of u. So u is x plus 1. plus a half. If I call that u, that's du. The integral of du over u is ln of the absolute value of u. The u is x minus 1. Plus a constant. Okay, now let's clean up the final answer. I can pull out a half. And I'm going to say this term first because it's positive. So I get ln of x minus 1 minus, because it is minus, I pulled out the half from here, so I get minus ln of x plus 1 plus c. But if you have ln, I don't want to say a and b, but if you have ln of a minus ln of b, well, you get ln of a over b. But the absolute value of one fraction divided by the absolute value of another fraction is just the absolute value of the fraction plus c. Now, if you want, you can leave it like that, or you can bring this up. And you get ln of the square root of the absolute value. Because 1/2 as a power means square root. So I will put or here. You can either leave this as your answer or the line below. Partial fractions, it can be a pain. It's a lot of simple work, but you have to know how to equate the terms, the coefficient. You have to be able to put in 0x squared and 0x's if you need to. Suppose you had the integral of 3 dx over x squared plus x minus 2. X squared plus x minus 2. The 3, it's in front. The derivative of the bottom is not the top, or the differential of the bottom is not the top. You're not going to get a u substitution out of this. Well, what you should do is try partial fractions. That is, get the denominator to be a product of things. That is, factor the denominator. Since it's x squared, you play x followed by a number game times x followed by a number. And you want the two numbers to multiply out as a constant, but add up to the number in front of x. Two numbers that multiply out to -2, but add up to 1, are +2 and -1. So I want to rewrite this integral as something over x plus 2 plus something over x minus 1 dx. And I'm going to spend a while from here on trying to find what goes above the x plus 2 and the x plus 1. Now remember, there's a 1 right here. So I want to rewrite that. I want to rewrite that. I want to rewrite this as something over x plus 2 plus something over x minus 1. Since this is a first degree equation, what goes on top is a 0 degree. That is a constant. First degree, constant goes on the top. Well, this is a times x plus 2 plus b, I meant to say x minus 1. I want to get a common denominator. I want the denominator to be x plus 2 times x minus 1. I want it to be this denominator here. So then I can say the numerators are equal. Well, the a, top and bottom, must get multiplied by x minus 1. the b, top and bottom. It must get multiplied by x plus 2. It must get multiplied by x plus 2. Okay. I really don't want to write on this right now. Okay, so now let's clean up the numerator all the way to the right and collect like terms. 1 over x plus 2 times x minus 1 is equal to ax minus a, plus bx plus 2b, all over the same denominator as to the left. Combine like terms. You have a plus bx. I have ax and I'm adding bx. I have plus 2b and I'm adding minus a. I have 2b minus a. All over x plus 2 times x minus a. X minus 1. Well, if the denominators are the same, and they are, well then the numerators must equal 0. On the right hand side, I have a plus bx's. On the left side, I just have 1. That's no x's. It's just 1. If it was 4, it's still no x's. It has no x's. 2a minus b, the lone constant. 2b minus a. 2b minus a, the constant. 2b minus a equals the constant on the left side, which is 1. Well, I ran out of room, but if you add those two equations, the a's cancel. But b plus 2b is 3b. And 0 plus 1 is 1. Divide by 3, we know that b is 1/3. And if you add a and b, you get 0. So a must be negative 1/3. So now I have the constants. A is negative 1/3 and b is 1/3. Okay. So the partial fraction portion with everything below this line. Now we're going to go back to the integration. Since it's friendly, this time I'm going to multiply by the 3. 3 times this, well, that's negative 1 over x plus 2 plus 3 times this is just good old 1 over x minus 1. It's the integral of that dx. Which means it's the integral of negative 1 dx over x plus 2. I'll pull out the constant negative 1. Plus the integral of 1 dx, which is dx, over x minus 1. For both of these integrals are straightforward. If I call either one of those u, then the top is du. You don't always get du over u, but a lot of times you do. Plus c. So we have negative du over u, the integral of du over u, which is ln of absolute value of u, and u happen to be x plus 2, plus, because it does say plus, the integral of du over u. Well, that's ln of u. Plus c. Well, whenever you're adding or subtracting ln's, you can write them as 1 ln. If you have a minus in front, then this piece goes in the bottom. Absolute value of x plus 2. You have a plus in front of the ln, which you take an ln of, namely the absolute value of x minus 1, it goes on the top. And the absolute value of one quantity divided by the absolute value of a second quantity is the absolute value of the fraction, plus c. There's your answer. Okay, these are somewhat boring because when we factor the denominators, we always got linear factors, first degree factors. What if we didn't? What if we got something larger than first degree? What if you have the integral of 3x squared minus 7x minus 2 all over x cubed minus x times dx? Suppose you have this integral. Well, you factor the bottom. And you get 3x squared minus 7x minus 2 over, you can factor out an x. Oh, isn't exactly what I wanted, but fine. Then you get x squared minus 1. But x squared minus 1 can be factored. X squared minus 1, why that can be factored to x plus 1 times x minus 1. So now we want to put all our energy into rewriting this fraction, x times x plus 1 times x minus 1, with an x on the denominator plus another fraction with x plus 1 on the denominator plus another fraction with x minus 1 on the denominator. Those factors. And since the first one is linear, I put a constant on top. Since the second one happens to also be linear, put a constant on top. Linear, I put a constant on top. Now, I'm going to rewrite down the fraction. And on the right side, I'm going to try to get the same denominator, which of course is going to be x times x plus 1 times x minus 1. I want to change the way that looks. I want it to have a different denominator. Well, if I multiply this denominator by that, I have to multiply the numerator by that. X plus 1 times x minus 1. I multiply by the missing factors. In the bottom, I have x plus 1 here. So I need to multiply by x times x minus 1 in the bottom to get this denominator. So I have to do the same to the top. I have to multiply by x times x minus 1, the missing factors. The bottom was missing x and x minus 1. X plus 1 was missing those two factors. What is this denominator missing? Well, it's missing x and x plus 1. So I multiply the bottom by it. Multiply the bottom by x times x minus 1, and now I get this denominator, but it no longer equals this. If I want to change the way this looks, I can only multiply by 1. I have to do the same to the top. That is, I multiply the top by the missing factors. Okay, that's all done. Let me erase this, please. Back, let me rewrite it. A over x plus b over x plus 1 plus c over x minus 1. Alright. Now, we need to clean up the numerator. We need to clean up the numerator on the bottom. Okay. Since the two denominators are equal, and we're claiming the fraction are equal, I know that the numerators are equal. Here we have ax plus a. We have ax plus a. Oh, let me not do that just yet. Sorry about that. This multiplies out to x squared minus 1. When I multiply it by a, I get ax squared minus a. This multiplies out to x squared minus x. When I multiply it by positive b, I get positive bx squared minus bx plus this multiplies out to x squared minus x. When I multiply it by c, I get cx squared minus cx. And the left side doesn't really change, but the right hand side I'm going to add up. I'm going to combine like terms. I have ax squared plus bx squared plus c x squared. And when it comes to x's, they're both minus. I have minus bx squared minus cx. I factored out the minus. Actually, okay, I factor out the minus. And when it comes to the constant, if I'm not mistaken, it's just negative a. Now I equate the constants. 3x squared is equal to this. Let me just write it down right up here, and then we'll solve it. A plus b plus c must equal 3. Minus that number of x's. Minus that number of x's. B plus c must equal 7. B plus c is 7. If I were to subtract them, they'll tell me a is negative 4. And I'm taking away 2, and here I'm taking away a. So a, it must be 2. Alright, so let me erase a lot of this. Let me erase a lot of this and continue on. Okay. Well, we know a equals 2. That means this must be 1. Which is a very big problem. Because if that's 1, I'm saying it's 1 because 2 plus 1 is 3. Well, if b plus c is 1, then the next line is a contradiction. So maybe we had a silly error. Let us see what's going on. Okay. This is going to become a times x squared minus 1. B gets multiplied by this, which is x squared minus x. And c gets multiplied by these two, which is x squared plus x. And it's going to be 3x squared minus 7x minus 2. So, how many x squares do we have? Well, we have ax squared, a, plus bx squared, plus cx squared. We have a plus b plus c, x squares. And how many x's do we have? I think that might be the error. How many x's do we have? Well, we have cx's, and we are taking away bx's. And what's the constant? The constant is just negative a. Negative a. And this is 3x squared minus 7x minus 2. That means this number must be 3. This number must be negative 7. Now we had b plus c. It should have been b minus c. And this number comes after the minus is 2. Okay, a plus b plus c is 3. And c minus b, or b minus c, that's our error, sorry. C minus b is negative 7. C minus b is negative 7, and negative a equals negative 2, which means a equals 2. Okay, sorry about that error. I know you all saw it. So now we want to solve this. We know that a is equal to 2, and that a plus b plus c is 3, and c minus b is negative 7. Well, a is 2. That means this is 1. 2 plus 1. Remember, that's 2. 2 plus 1 is 3. So, b plus c is 2, and c minus b is negative 7. If I add them or subtract them, well, if I add them, the b's cancel, and I get 2 c's is negative 5. So c is negative 5 over 2. And I guess I know that b plus c is 2. So b is 2 minus c. But c is negative 5 halves. So you have 2 plus 5 halves. 2 is the same as 4 halves. When you add 5 halves, you get 9 halves. So now we have b and c and a. So a is 2, b is 9 halves, and c is negative 5 over 2. Alright. Not a big deal. A lot of work just to find out what the a's and the b's and the c's are. Well, the integral of this mess, which is what they originally asked me to find, integral of that mess dx, is the integral of this dx plus the integral of this dx plus the integral of that dx. And I can factor out the a's. It's the integral of dx over x with the a in front. The a is 2. I can bring the b in front. Plus b, the integral of dx over x plus 1. Plus, I can bring the c in front. But the c is negative. Adding a negative 5 over 2 is the same as just taking away 5 over 2. The integral of dx over x minus 1. Okay, the columns I'm picking seem to be always making me look like a liar. I said you don't always get LNs. I should have said this, and I knew this from the get-go. A lot of times you get ln. This integral outright is ln of absolute value of x plus 9 over 2. If that's u, that's du. That is, you get ln of the bottom, the absolute value of the bottom. Minus 5 over 2, if I call that u, well, that's du. So I get ln of the absolute value of the bottom. I can bring these numbers up. I can bring these numbers up. So I get ln of absolute value of x squared. But x squared is never negative, so you don't need the absolute values anymore. Plus ln of absolute value of x plus 1 to the 9 halves minus ln of absolute value of x minus 1 to the 5 halves. I'll write this as 1 ln. Since there's an understood plus in front, the x squared goes on the top. I didn't mean to put a bar there. X squared goes on the top. Since there's a plus in front, x plus 1 in absolute values to the 9/2 goes on the top. Since there's a minus here, the absolute value of x minus 1 to the 5/2 goes on the bottom, plus c. This ln of what's in that those big brackets, plus c. Now, suppose you have a problem that's like this. You have x to the 4th dx, and you're dividing this by x minus 1 cubed. X minus 1 cubed. This is a partial fraction problem. If you let the whole bottom be u, du will not be x to the 4th dx. If you let u equal x minus 1, well, you can do that. If you let u be x minus 1, well then du will be dx. And so this piece is u cubed. This piece du, x to the 4th. Well, if you add 1 to both sides, you'll get x. And then you raise it to the 4th power. And then you look at Pascal's triangle. 1, 4, 6, 4, 1. You should know this, but if you don't, somehow figure out what u plus 1 to the 4th is. It's going to be u to the 4th plus 4u cubed plus 6u to the 4th, I meant to say squared, plus 4u plus 1. Okay, so obviously I need a little bit more room. The nice thing now is you can do the division. U to the 4 plus 4u cubed plus 6u squared plus 4u plus 1 du. Now you do the division. That is, you do u cubed into u to the 4th, you get u cubed into 4u cubed, you get 4, u cubed into that, you get 6 over u plus 4u divided by u squared, u cubed, you get 4 over u squared, but I'll write it this way. And then you get 1 over u cubed, which I'll write this way. Because it's easier that way to take the integral. Okay, now, u was equal to x minus 1. We can't forget that. Problem's done. You get u squared over 2 plus 4u. This integral is ln of u plus 4. Add 1 to the power. You get negative 1. So it's u to the negative 1 over negative 1. Add 1 to the power, divide by that power, plus c. Let's clean this up a little bit. ln of u plus positive 4 over negative 4. Well, that becomes negative 4. And u to the minus 1 goes on the bottom. There's a 1 there. A positive 1 divided by negative 2 is negative a half. U to the negative 2 goes on the bottom is u squared. And then you substitute in whatever x was equal to. You substitute in what x equals. U was equal to x minus 1. That should be a plus like it was right above. There's the answer. That's doing it. That's the way you should do it, in my opinion. But this section is entitled partial fractions. And that's how we're going to do it. Whenever one of the factors is raised to a power, you're going to have something with x minus 1 cubed in the bottom, and something with x minus 1 squared, and something with x minus 1. That's what you do when you have one factor to the third power. If you also had x squared plus 1 in the bottom, which cannot be factored, you would also have a plus x squared minus x squared plus 1 in the bottom. Now, what's inside the parenthesis is to the first degree, so we put a constant on top. What's inside is first degree, put a constant above it. Don't call it the same letter, please. You have a constant, call it, first degree, call it C. Here, x squared plus 1, that's a quadratic. We're up to D. You would put dx plus c. Now, if this was raised to the second power, you should have it to the second power, and then also to the first power. Since it's a quadratic, d plus e, dx plus e. Now I would put fx plus g. It's a quadratic, second degree, I put a first degree on top. But it never did have that. That was a what if problem. Okay. So, integral times dx. So now I want to get a over x minus 1 cubed plus b over x minus 1 squared plus c over x minus 1. I want it to equal this. I want it to equal x to the 4th over x minus 1 cubed. And I want to get the denominators to be the same, namely x minus 1 cubed. Well, the denominator there is already x minus 1 cubed, so the top stays the same. Over here, I would say, it does say plus. Over here, I would have to multiply the denominator by x minus 1 to get this denominator. And since I do have that denominator, I have to do the same to the top. Okay, plus. I need to multiply that denominator by x minus 1 squared, which is x squared minus 2x plus 1. Top and bottom. In order to have x minus 1 cubed on the bottom. Okay. So we clean up the numerators and we set it equal to x to the 4th. 1x to the 4th. Interesting. Very interesting. How about x squared on top instead? How about x squared on top? So now, this is equal to a distributing plus bx, etc. Plus bx minus b plus cx squared minus 2cx plus 1c. All over x minus 1 cubed. And I want it to equal to x squared over x minus 1 cubed. This is supposed to equal to x squared over x take away 1 cubed. Since the denominators are both the same, I equate the numerators. X squared must equal this numerator must equal this numerator. But let us clean up that numerator. How many x squares do we have? Well, looks to me like we have cx squares. How many x's do we have? Well, we have plus b minus 2cx's. What is the constant? It's a minus b plus c. And that equals x squared. Excuse me, that should say x squared. 1x squared. So c should be 1. 1x squared plus no x's plus no constant. C should be 1, b minus 2c should be 0, and a minus b plus c should be 0. Well, if we know c equals 1, we're done for c. And we know that 2 minus bc is 0. But that's 2. 2 times 1 is 2. b minus 2 is 0. b should be 2. 2 take away 2 is 0. So now we know b. And we know that I'm copying this here, a minus b plus c should be 0. Well, should be 1. If a was 1, 1 plus 1 is 2, take away 2 is 0. So a is equal to 1, and we already know that b is 2. Here is our answers. All that work just to find out what the values of some constants are. And this is almost silliness, because what do we do with the constants? We factor them out in front. Okay. So this is equal to the integral of this, the integral of a dx over x minus 1 cubed, and the a comes in front, which is 1, plus b over x minus 1 squared dx, the integral of that. The b comes in front, and we get b dx, or 2 dx, over x minus 1 squared, plus 1 times dx over x minus 1. Okay, here's a case where we are not getting all ln's. We're getting ln for the last one. What I'm going to do is I'm going to rewrite this as x minus 1 to the negative 3 dx. I don't need to write the 1 in front. Plus 2 times the integral of x minus 1 to the negative 2 dx. Plus I'll leave this last integral. Now, if u equals x minus 1, y du will just be dx. This is u to the negative 3 du. Add 1 to the power, divide by that power, plus there's a 2. This is u to the negative 2, and that's du. Well, add 1 to the power, divide by 1, plus, if this is u, why, that's du. Integral of du over u is ln of the absolute value of u, plus c. Okay, we clean up and we substitute back x plus 1 for u. Okay. So, an understood positive divided by negative, that's negative. The 2 stays on the bottom. And u to the negative 2 goes on the bottom is u squared. And there's a 1 on top. Positive 2 over negative 1 is negative 2. I'll move the u to the bottom. U to the negative 1 to the bottom, it's just u. Plus ln of u plus c. And then I just rewrite it. Instead of u, I put brackets. or absolute value bars, and I put in what the value of u is. Whenever you have a factor in the denominator that's being raised to a power, you have to have one of the denominators be that function to the power, and then that base to the power, and then that base to one less than the power, and another denominator with the base even one less, and another denominator with the base one less, until you get to 1. For example, suppose you have 2x minus 1. Well, since I don't like the 2, how about just x minus 1? All over x cubed minus x. Or x cubed minus x squared. Suppose you were asked to solve this integral. Well, this is x minus 1 over, I can pull out an x squared, and then I'm left with x minus 1. So let's make this x minus 4. Otherwise, you can say the x minus 1's cancel. dx. So I want to write this as how have I been handling that before? I haven't been doing these wrong, have I? No. Okay. So I'm going to have the integral of something over x squared. Well, we need to talk about this a little bit. So I'm just concerned about the denominator. I'm concerned about the denominator. X minus 4 over x squared times x minus 1. Now there are two ways to think of the x squared. You can just think of it as x squared, like x squared plus 4, or x squared plus 0. You put an x squared on the bottom, and then since it's square, second degree, you put a first degree polynomial, ax plus b, plus x minus 1, since it's the first degree, you put a constant on the top. Or you could have thought of x squared as x being squared. So then you're going to have an x squared plus just an x to the first. And since this is linear, you're going to just put a constant, a. And since this is linear, you just put a constant b. And let's not forget the x minus 1, c. Now, if you got this, this is equal to this. Because if you multiply top and bottom by x, the top will be bx and the bottom will be x squared. And what do you know? The denominator is the same, so you get a plus bx on top. Exactly what we got. So it's up to you if you want to think of the x squared as just x squared or x, something to the second power. Either way, you get it right. You get the same exact result. Okay, so now we want the denominators here to be the same. X squared times x minus 1. We want it to be like this. So the ax plus b, it already has the x plus x squared. It needs to be multiplied by x minus 1. And the c already has the x minus 1. It needs to be multiplied by the x squared. So we get ax squared ax squared minus ax plus bx minus b plus cx squared, which is a plus c x squared, a plus cx squared. I hate negatives, so I'm going to write the positive x's first. I have b x's, and I'm taking away a. That is, I have b minus a. And the constant is just negative b. And this should equal the other numerator, x minus 4. X take away 4, not equals. X take away 4. 1x take away 4. It has no x squares. It has 1x, and it is taking away 4. That is, let's write it to the left. A plus c should be 0. B minus a should be 1. And b is 4. Well, if b is 4, then a is 3. 4 minus 3 is 1. So b is 4, and a is 3. A is 3. So let's write it cleanly. A equals 3. That implies a is 3. And if a is 3, then c must be negative 3. If you add two numbers and you get 0, the signs are different. If a is plus 3, then c is negative 3. Okay. So what we have is the following. Integrating this, which was our original function dx, is the same as integrating this dx plus integrating this dx. But now we have the a, b's, and c's. A is 3, b is 4, and c is negative 3. So let me erase a lot on the bottom. And then we will go back to the calculus. A lot of algebra courses, basic algebra courses, have partial fractions in it. Okay, so this is equal to, I'm copying this, 3x plus 4 over x squared, that dx, plus c is really minus 3 dx. I'll factor it out over x minus 1. Okay, now the first integral, I will separate it into the sum of 2. It's the integral of 3x dx over x squared. The 3 I put in front. But x over x squared is just over x. Plus the integral of 4 dx over x squared. 4 dx over x squared. The x squared I'll write on the top as minus 2. X to the minus 2. Minus the 3 dx over x minus 1. Most of these integrals are pretty standard, if not all of them. This one is dx over x, 3 times that. That's 3 ln of absolute value of x, plus, now, this one, I make the power 1 more, and I divide by that number. 4 over negative 1 is not plus, but rather minus 4. And x to the negative 1 goes on the bottom as x. Minus that integral, minus 3. Then integral of dx over x minus 1 is ln of x minus 1 plus c. If you wanted to, you could combine their ln's. In fact, not only can you combine the ln's, but you can pull out this 3. I can pull this 3 out from here, and this 3 out from there, and I get 3 times ln of x minus ln of x minus 1. But ln of x minus 1 is just that. And let us not forget to take away 4 over x, and certainly not to forget to add c. Okay, that finishes the section on partial fractions.